So this is the last piece of new material for this class. This is the stuff that goes with 7.2, and it's chi-square tests again, but we're going to be talking about chi-square tests for association. So in 7.1, we were talking about doing inference for a bunch of proportions, but the proportions we were talking about were subsets of one categorical variable. So we were talking about Taco Bell sauce, and that had a bunch of categories, right? It had Diablo, hot, and fire, and mild. So that's just one categorical variable. But we can also do a test for an association between two categorical variables, and we would use a chi-square test for that kind of inference as well. So this is some data from Pew Research. It just got released, and it's about political party and then people's opinion about media response. So they asked a bunch of people, a representative sample of Americans, if they think the media is getting me the information I need or not getting me the information I need. And we have the counts for people who said that it was getting them the information they needed versus not, for conservative Republican, moderate Democrat, and liberal Democrats. And we might want to know, is there some association between people's opinion about the media and their political party affiliation? So those are both categorical variables. If we were thinking about the original data set, we would have something like the political party and then the opinion. And this might be conservative, Republican, and might be conservative, Republican, and not getting, could be moderate, Dem, and not getting, right? That's what the original data would have looked like. It would have two variables and be going down like that. And now we could get the information into this two-way table. It's more than a 2x2 table. It's a 2x4 table, it looks like. So we've done inference on a 2x2 table before, and now we're kind of extending that again. So if we're going to do some inference, again, the only type of inference we're doing is hypothesis testing, and we're going to start with step 1 to state the hypothesis. And our null hypothesis is always there is no association between variable A and variable B. And the alternative hypothesis is there is an association. So in this example, if we were thinking about the political party and the responses, there is no association between political affiliation and beliefs on media and COVID-19. And the alternative hypothesis is that there is an association. All right, so now that we have our hypotheses, we need to compute our test statistic, and we're going to do it the same way that we did in section 7.1. We need expected counts, and the way that we're going to find the expected counts, now that we have a more complicated situation, is we're going to take our row total times our column total over the n, the total sample size. So let's do an expected count here for the getting the information I need and conservative Republican. So I'm going to put it in parentheses right here. And the way that I'm going to compute it is I'm going to do the row total 2129 times the column total 5891, and I'm going to divide by the total 8128. And that expected number is 1543.054. So that's the expected number. And we could come up with an expected number for each of the cells in this entire table. So in 7.2, it's getting more complicated because there's a lot more arithmetic to do, but it's basically the same procedure that we did in 7.1. So here I have found all of those expected counts. And one thing that I'd like you to notice is that the rows and columns still add up to the totals. So if I did 1543 plus 818.3 plus 1672.8 plus 1856.9, that adds up to this column total. And the other column total adds up, and if you add it across in the rows, like 1543 and 585.9, that would still add up to 2129. So all of the counts are the same. We have the same number of conservative Republicans. We have the same number of people who said that they were getting the information they needed from the media, but we've distributed those counts the way they would be if there was no association between the variables. So once we have the observed and the expected counts, then we're going to compute the chi-squared statistic just the same way we did for the goodness of fit test. There's going to be more numbers here. So now I'm going to have 8 things that I need to add together instead of just a couple. So to save some of that arithmetic, I've done the observed minus expected squared over the expected using R, and that's what I've got over here. And then I can just say I'm going to do the sum of the observed minus expected squared over the expected, which in this case is going to be 156.88 plus 413.32 plus 9.75 plus 25.67 plus 40.16 plus 105.77 plus 55.87 plus 147.14. So those are the contributions of each of those cells to the chi-squared statistic. And so if I sum all of that up, that's going to turn out to be 954.56. So that's my chi-square statistic. And now that we have a test statistic, we're going to need to find a p-value. Again, we could use a randomization distribution, or we could use a chi-square distribution. And I'm going to show you how to do both of those. So we're going to start by doing simulation in StatKey. So let's go to StatKey. This time we're looking for a chi-square test for association. And again, I'm going to need to edit the data because this was an example that I found on the internet. All right, so now I have the same data that I had in my slideshow, but it is on StatKey, and I can see the same chi-square statistic that we just computed, the 955. So if I click generate one sample, what it's going to do is it's going to mix up the labels for one of the variables. And again, it's going to make sure that the counts come out the same way, but as if there was no association. So it's a little hard to see here, but the chi-square statistic for this randomization sample was 4.945. So we've got a dot on the plot. I could click generate one sample, get another one, generate one sample, or be really lazy and just click the generate 1,000 samples button. So now I have something that looks kind of like a chi-square distribution. It's a randomization distribution. And then I could ask it to find me the right tail and switch this number from 8.764 to be 955. And basically it's saying my p-value is 0. It would be so strange to see something that extreme if the null hypothesis were true. So if we use randomization, which is a simulation method, we find a p-value that is approximately 0, and so we can reject the null. We have evidence to suggest there is an association between political affiliation and beliefs about media and COVID-19. So that's one way to find the p-value. The other way would be to use the chi-square distribution. We still need to check that the expected counts are greater than 5. In this case, we're going to need to check all of the cells. And if that condition is true, then we're going to find a p-value. It's always going to be the right tail in the chi-square distribution. And the way that we find is the degrees of freedom is the rows minus 1 times the columns minus 1. So let's think about the chi-square distribution here. Let's go back and look at our table. So all of those expected counts are greater than 5. And I have 1, 2, 3, 4 rows and 2 columns. So all expected counts greater than 5, so check. And then I've got 4 minus 1 for rows and 2 minus 1 for columns. So that's 3 times 1 is 3. So the degrees of freedom are going to be 3. And again, we can go back to stat key. We're going to go to theoretical distributions, chi-square distribution, click on that, and then put in our degrees of freedom, which is 3. And then again, I'm going to click the right tail button. And I'm going to edit the 9.348 to be my observed chi-square statistic, which was 955. And again, I'm going to get a p-value that is basically 0. So my p-value is equal to 0. And so again, we can reject the null. So it doesn't matter if we used the randomization distribution or the theoretical distributional approximation. We're going to reject the null either way. So then just as an overview, when we're doing a chi-square test for association, our first step is always to state the hypotheses, and they're always going to be the same. The null is there is no association, and the alternative is there is an association. We're still computing a test statistic using the sum of the observed minus expected squared over the expected, but it's maybe a little more complicated to find the expected. That's the row total times the call total over n. Then we can find the p-value one of two ways. One would be using the randomization distribution, and the other one would be a chi-squared distributional approximation. For that chi-squared distribution, you need to check all expected counts are greater than 5, and the degrees of freedom are equal to the rows minus 1 times the columns minus 1, and you always use the right tail. And then, of course, the last thing is to interpret the p-value in context. So that's how we do inference when we're looking for association between two categorical variables. We're essentially doing inference for a bunch of proportions.